Thanks so much, Sarah. And thank you everyone for joining. I'm so excited to see so much interest and early engagement in this webinar series. I will definitely throw in the chat the next dates for sessions 2 and 3. But focusing now on today's session, we're so excited to have you join us as we kick off with a foundational look at artificial intelligence and generative AI, specifically in economic development. Very much catered to all of your work at that broad high level of economic development. So today's session is all about building a shared understanding of how these technologies work, how they learn from data and generate content like text, images, or in some cases, even code. We'll also explore how AI can help streamline key tasks in your economic development work, such as grant writing and content creation to gathering your needed data. And we're joined today by two fantastic speakers from RTI International, from our side of the community of practice, and that is Jacob Smith, who is an innovation advisor with a special focus and interest in AI, and Mike Hogan, a senior economic development analyst, who's bringing that tailored economic development perspective. So their expertise really blends perfectly together to deliver cutting edge AI tools and information through that lens that we're all striving for. So without further ado, let's dive in. I think, Jacob, you are opening up.
Yeah, absolutely. Thank you all for the introduction. It is a pleasure to be here. I will go ahead and start to share my screen here, and let me know with a thumbs up if you all are able to see it. Perfect. So, as we start this presentation, the first thing I'll note, being an AI enthusiast and kind of working on implementing AI into the workflows that I'm doing on a daily basis, is the title slide of this presentation was actually generated using generative AI. So this was Mid-Journey used to create this light bulb style neural network type image to highlight innovation, which is really kind of what AI is kind of helping everyone out with in these days. And it's really accelerating a lot of things. So in the invite, we noted we would cover a lot of kind of AI 101 topics. So we'll look at what is AI, what is generative AI, what are the benefits and limitations, specifically some that are very relevant to economic development workflows. And then we'll look at some tools, actually like shared screen, and show you how easy it is to access some of the tools. Some of you might be familiar with them, and for others, it might be a great intro to how easy it is to get access to them. And then we'll actually look at some demos of using these tools as part of economic development workflows. So I will go ahead and dive into the presentation and get started with the overarching question of what is AI. So at the highest level, artificial intelligence is a field that involves the creation of systems that imitate human intelligence. So it's an entire field of computer science that's focused on creating these systems that typically require human intelligence. So learning, decision-making, pattern recognition, that type of thing. I'll also highlight the image on the right was one, again, that was generated using Mid-Journey, generative artificial intelligence platform. So to get a little bit more into the specifics, I said AI is an entire field of computer science. So what does that exactly mean? How is generative AI related back to the AI that came before generative AI? So this diagram highlights at a high level some of the different subtopics within the field of artificial intelligence. So I'm sure some of you are very familiar with some of these other types of AI that weren't really hyped as AI because AI had this kind of negative stigma associated with it for so long. So kind of in the most basic bucket, you have what's called symbolic learning. So if you've ever used if-then type rule-based, logic-based system, if this condition is met, this action is triggered, that's kind of the symbolic type of artificial intelligence. machine learning is really the field that has exploded over the course of the past, maybe 10 years or so, and seen some really cool applications. And machine learning is all about pattern recognition. So just like humans, as we intake information and we start to associate certain things with others, it's really what the whole purpose of machine learning as a field is. So within machine learning, there are a few different subsets that are really important to the discussion that we're going to highlight today. And when you think about all of those subsets, they kind of fall into two larger buckets. There are discriminative AI models. These are models that learn the boundaries between classes of information or data to predict things, to categorize things, just find patterns in that data. Then there's generative models that learn kind of the underlying distribution of a vast quantity of data and use what it's learned from that data in order to actually generate new content that stems from its learning of that data. So within machine learning, there are two kind of big buckets that I want to discuss today. One is statistical learning. This is basically taking a set of data, maybe for instance, if you're in manufacturing, you have sensors on a particular machine, you're measuring a few different things, you have it in a spreadsheet, then you can do machine learning on that data to find patterns within that data. And then you can use the model that's created from learning from that data in order to make some sort of prediction or maybe classify when a particular sensor reading is actually out of line with what the model would anticipate. So you could do, something like predictive maintenance or something along those lines. It's very much based in statistics and looking at using statistical methods to kind of look at the patterns that are found within that data in order to create a model that you can use for that classification or prediction. So it can get really complex, definitely. And certainly you can use really big spreadsheets and data sets in order to build these models, these machine learning models that can help you do this. But the other type of machine learning that we'll discuss today is actually the one that's even more complex than that traditional machine learning. And deep learning, at its core, the reason it's different from machine learning is it uses what's called a neural network. So just like we as humans have this network of neurons in our brains that inspired the name for the neural network, these deep learning models actually take data and they find really deep associative relationships between the different pieces of that data in order to provide users with either maybe a classification output or maybe in some cases, since generative models are actually a subset of deep learning, to create new content. So on the classification front, you might think of deep learning in the sense of, maybe you're doing image classification. So images are made up of pixels. Those pixels are all tiny pieces of data. But when you think an image is tens of thousands of pixels or a video is millions of pixels and you're trying to pick things out, it requires a little bit more of a robust determination of the association between those data points to be able to make those classifications. So deep learning, you would think of in those cases where you're doing like tracking an object in an image or maybe quality control. And we'll get into some of those examples. And then we have generative models at the end, which are deep learning models that are specifically created to generate new content based on the data that a model was trained on. So when you think about ChatGPT, for instance, they fed the algorithm the entirety of the internet that they had that was accessible to them. And then I'm sure some of you know maybe some things that they shouldn't have fed the model to train it on. And ultimately, they end up with a system that can take in a user prompt, run it through the model, and get a completely new output from the other side of the model. So to give an overview of what some applications are within AI, I think one of the key takeaways that is important for folks to understand as you start to think about how to apply AI, it's important to match the type of AI with the application. because some types of AI are much better suited for a particular application. For instance, if you're looking at trying to predict which businesses in an area might close, you don't need necessarily a deep learning network that has trillions of parameters when all you have are 6 different sets of data in a spreadsheet that you can create a much simpler model to make that classification. So we've talked a little bit about symbolic learning, those rule-based systems. You might be able to use those to determine eligibility for an incentive or something like that. Tools like Salesforce Flow allow you to encode those type of rules and in a rule-based system that can help automate that process in some way, shape, or form. For the statistical learning piece, maybe we already talked about this example, predicting which manufacturers are at risk of closure. You might have credit scores, you might have, some financial metrics or something. You can look at patterns over time using a simpler model building tool like Google Vertex and AutoML, which is a tool that best matches a particular machine learning model to the outputs that you want. And you can use it to forecast data, predict things, classify things in a simpler fashion. On the deep learning front, these are those big neural networks that we discussed, much better for things like images, audio, video, and large bodies of text. There are some applications that we talked about, like classifying industrial land from aerial imagery. Maybe you're doing quality control or defect detection. And there are specific tools that are geared towards this type of application. So deep learning tools that you can fine tune and customize to pick out different things from satellite or drone imagery, or tools like Tulip Vision that you can use in the factory for real-time visual inspection of parts, misalignments, defects on the line, those types of things. So we talked a little bit about discriminative AI in those 3 classes, but really back in 2022, when ChatGPT came out, is when AI kind of really exploded. And so the majority of the presentation today will focus on generative AI and the application of generative AI within economic development. So generative AI is a sub-branch of deep learning, like we discussed already, where the models go beyond classification to actually generating content. So they're using advanced algorithms and models to create this content. And these days, the frontier models are capable of generating text, images, audio, video, code, there's many more, any type of data you can think of. You could, if you had enough of it, think of being able to take that data and turn it into some form of generative model. So these models create data based on the patterns they learn from their large data sets. So this is another image that I generated using AI, and then I also used AI to turn it into a short video. And this is a very simplified example, but you all may have already been seeing in the media ads, movie trailers, things like that have been completely generated by AI. So we've really accelerated in the capabilities of these generative AI systems. And what I think is important to note about this particular technological progression is the pace at which it's occurring. So for things like smartphones, it maybe took about 2 years to get 100 million annual users. But with generative AI, it took 0.2 years to get 100 million monthly users. So these tools are extremely easy to access, extremely pervasive, and they're being used by a lot of people across the globe because of how useful they are. So you can see on the timeline here, this progression from late 2022, whenever ChatGPT was first released to the public. You could ask it a basic question. It may or may not give you the right answer, but very quickly over time, in less than 3 years, we've gone from a basic question answer chatbot to these large language models that form the foundation of ChatGPT that have reasoning capabilities. They can now access and scrape the web. They can retrieve context from documents that you upload to them. And with this reasoning capability this year, we've really seen the explosion of AI agents. So an LLM serving as kind of the center of a system that can perform actions on a user's behalf. So no longer are you getting a prompt and an answer, but you're actually putting in a prompt. The model is reasoning, performing some actions based on the conclusions that it comes to, and then bringing you back an answer. And it's moving so quickly that next year, and already it's happening some this year, but multi-agent systems are going to be starting to emerge in lots of different industries over the course of the next few years. So to give you an idea of some of the high-level tasks that generative AI-powered tools can augment within economic development workflows, I've provided a short list here, but really the limit of generative AI is kind of the limit that you can find through experimentation. So these are some very basic examples: drafting and writing content. So there's drafts of grant proposals, emails, press releases. You can look some of the other examples here. Summarizing information. Maybe you have a lot of documents that you need to take and develop some key insights from. Maybe it's meeting notes, scenario planning. You can actually use these models to simulate what if X, Y, or Z happened to determine what the potential impacts might be on some of these parameters that you see here. You can use these models to help interpret data. So what started as ChatGPT in 2022, it was all text-based. All you could do was ask it a question, put in some text, and get an answer out the other side. The models today, the frontier models, so ChatGPT, based models from OpenAI, the Google Gemini family of models, the Anthropic Claude family of models, they're all multimodal. That means that not only can they analyze text data, but they can actually analyze videos, they can analyze images, and help provide an actual interpretation of what's seen within that data. You can use it for outreach and engagement, which we kind of talked about, training and onboarding, synthetic content generation. So in cases where maybe there's some very confidential or proprietary data that you don't really want to get out there, you can create synthetic versions of that that are not using the real data in order to help get a better understanding of a situation or simulate scenarios. And we talked about the multimodal analysis, but these models are really getting to the point where they can look at a chart and analyze the data that is in that image and give you a kind of a textual response based on that content. So at a high level, I think the key takeaway from this section and the last section is generative AI, even though it is all the hype right now, it is not the only type of AI that exists. And really the job of AI is to take heterogeneous inputs, body of data, do machine learning on that data, develop a model that can provide you with actionable outputs at the end of the day. So for some use cases, a discriminative AI model would work best. These are those custom, smaller, less complex models that can give you forecasts, predictions, do classification. Or in some cases, maybe you have a really huge body of text or image data, and you actually want to try to glean some more in-depth insights out of that data, generate ideas based on that data, or generate content or curate content as a result of what is within the data sources that you have. So in getting into some of the benefits and limitations of AI, and specifically generative AI, I showed that list of all of the very basic applications that you could use within economic development workflows. And these benefits are mapped directly to that table. So you're saving time, really. When you look across all of these, there's a lot of doing things more quickly, more efficiently. It actually can improve quality in some cases if you have enough good examples to feed to a model to help improve, professionalism, help support communication, clear communication to different stakeholders. It can support strategic foresighting and brainstorming activities. It can make information more accessible for partners, the public, elected officials. It can enhance kind of visibility and responsiveness because it's able to do such a good job of generating content without having a specific expert that uses very complex set of tools in order to do those types of activities. It can help build capacity. It can be used to help prototype things. So many of you may have seen examples of where you can actually generate images of different concepts that you might have directly within an LLM chatbot platform. And then again, the faster analysis, looking at different types of data that you may have across your region. And I'll highlight again, there's so many more benefits that you can extract from these tools. You just kind of have to push the boundaries through experimentation. So with a list of benefits also comes some very unique limitations associated with these tools and the models that they're built upon. So within this chart, I've separated these limitations into three categories: technical, human-centered, and operational. So some of you who have been familiar using these tools may have experienced some of these limitations. So particularly in the earlier models, things like specificity were not so great. You might get overly broad or vague outputs. But if you use clear, detailed prompts, you can slightly mitigate that specificity issue. And we'll get into prompting in a couple of slides here. There's maybe issues with relevancy and accuracy. So many of you might be aware that these models can hallucinate. You know, at the end of the day, the models are a bunch of ones and zeros, and your prompt is being converted to ones and zeros and matched within this massive neural network. And sometimes the relationships that are made within this neural network during the training process aren't necessarily accurate. So you have to be very careful that you're reviewing the outputs of these and leveraging systems that actually give you citations for the content that's being generated is a best practice here. So homogenization, these models are all trained on a very similar set of data, the internet. And with that comes the issue of no matter what model you use, you may get repetitive or similar outputs from the models themselves. And one of the ways, or some of the ways that you can mitigate that, are continuing to provide your own experiential input as you're using the tools, using augmented data sets through retrieval augmented generation, and using diverse prompting strategies to really get variation out of the platforms. A big issue that we hear about a lot is data privacy and security. So the tools we'll show today are all public tools. If in some cases, the tool providers and the model developers will actually take the data that you input into the tools and use it to train the next iteration of your model, which could lead to some serious issues with leakage of that data or information that might be proprietary out into the public. So it's critical to be very careful what you put into publicly available tools and really take into serious consideration whether your organization needs a more secure platform. All of these tool providers, many of them are still not super profitable at this point. They're spending more money training models and developing software than they are actually making on the users of the platforms. They're really trying hard to solve this problem to get folks comfortable with using it. So enterprise subscriptions to tools that include data protection, privacy, and security, and making sure that your information is not actually being used to train the models where it can be leaked back to people in the next release. It's a really critical point here. On the human-centered side, I think a couple of the key points here are really related to biases. So these models were trained on the internet. The internet was written, most of the content on the internet was written by individuals that have significant bias. And that bias is reflected in the way that the model found patterns in the data. So the outputs of the models can actually be biased themselves. And it's something to keep in mind. And in order to mitigate that bias, having the human in the loop, making sure you're using data that you trust as part of the input, and including more diverse perspectives as you think about prompting and evaluating your outputs is really key here. Then this one is an interesting one, and it's one that um, I don't see talked about a lot, but as people become more comfortable with these tools, it's going to become a much larger issue. So, this automation bias or over reliance on AI, where the response from the model sounds so realistic that you trust it without actually verifying what the output is. Um, these models are inherently built and reinforced to give you answers that sound realistic. The people who are training them are, giving the thumbs up and the reinforcement training to make sure that that is the case. So you have to be very careful to make sure that you maintain oversight over the outputs of these models. Continue to think critically about how the question you're asking and the answers that are coming out are actually what you're hoping for and not just trusting and actually based on data. And these outputs are an augmentation of our own human centered processes rather than a fully automated source of the truth, because there's many examples where these models have hallucinated in even critical situations, like hallucinating case law and things like that. And then the last one here is relatively straightforward, but the idea that these tools are new, technology is moving so rapidly, and it can be hard to encourage adoption or get people up the curve to use this new fast evolving technology. So giving people room to experiment, giving people opportunities to receive training on the tools, attend sessions like this, like we have today, and continuing to promote that experimentation is key, because there are, even if you asked an LLM itself to give you an exhaustive list of all the ways that you could use AI as part of an economic development workflow, the list would inherently have gaps in it that someone just hasn't uncovered at this point yet. So, one of the key things that I think is really important to understand when it comes to leveraging generative AI is the importance of prompt engineering. I myself didn't think too much about prompt engineering until maybe 8, 10 months ago, after reading a few academic articles on it. And prompt engineering is essentially taking a query that you have and making sure that you're providing the right context to get the best response from the model. So the chart shows that the default performance with a very simple basic prompt will give you not it will give you a not a low model performance, but kind of the default answer. But as you increase the quality of your prompts, you can actually get closer towards that asymptote of max theoretical performance out of a particular tool that you're using. So there are a lot of resources out there related to prompt engineering, and it's almost overwhelming to a certain extent because there are so many. But the one that I want to highlight today is the prompt canvas. And I will actually, once I swap screens in a moment, I'll drop in the article, the peer-reviewed research article on the prompt canvas, as well as the PDF of the prompt canvas itself that breaks down kind of the best case scenario for a prompt. So I'll show you an example of a good prompt, or a prompt that was created using the prompt canvas. And you'll see here, it's an entire page of context. So the prompt canvas itself has 8 different categories that you can see here in bold: persona role, target audience, task intent, a step-by-step set of instructions, context, references, and notes about how you want the output to be format, and then the tonality of the output. So these LLMs have gotten really good at being able to walk through these prompts and actually perform the actions or the tasks that you want in a very structured way. So this might look very different than how you used an LLM before, but we've found over time that really getting a feel for prompt engineering and starting to think, okay, well, I can give the LLM a role. I can tell it who this output is for. I can give them the specific step-by-step instructions for the task that I want to be performed, and then specify the output. You can do so many really cool things with this. So previously, maybe you've only gotten a paragraph output or bullet output. These models can give you a perfect table that you can copy and paste out the other side. It can give you, very specific bulleted list. It can give you word delimited paragraphs of information or summaries. So particularly for applications where you're maybe taking a very large document and you're developing it into a social media post or something like that, you can provide the specific context for all of the things that you might have had to do afterwards right within the prompt and get a much better output up front. So now that you all are prompt engineering experts, I want to talk a little bit about the tools that are available and how you access them. So there are an overwhelming number of tools in the marketplace, but when you really look at the landscape of these tools, there's kind of three different tiers. There are the companies that are developing these foundation models. The big tech companies are really some of the only ones that have access to the resources required to do that, the massive data centers, the compute, the money in order to buy all of that, the energy required for all of that. These model providers also do provide primary software applications, applications that are built on top of those models to allow users to interact with them. Where we're really seeing a massive explosion is in these third-party software applications that are essentially wrappers built around a model from these foundation model providers. So Copilot is one example that uses a lot of OpenAI technology and models within its system. Perplexity is another one that some of you might be familiar with, but there are thousands. There are so many tools where really these developers have either built in some simple algorithms on top of the model or engineered some system prompts that get the model to behave in a very specific way for a particular task that makes it much more domain specific at the end of the day. So all of these applications, especially the ones from the foundation model providers, typically have free and paid access. And I wanted to take a moment to just walk through a few here. And I know I want to give time for Mike to be able to walk through his specific use cases. So I will go pretty quickly through these examples, and I will drop in the chat now the prompt canvas framework and article for those of you who are interested, because I'm going to use it as part of the next example here. So I will go ahead and reshare my screen. So how many of you all have used ChatGPT before? I see many hands being raised in the audience. There are a lot of different versions of ChatGPT. I do have the pro version, but what I'm going to show you today is actually not, you don't have to have the pro version in order to do this. So that really complex prompt that I just showed you, it would be kind of a pain to actually type out all of that information, right? What if you could use an LLM to actually help you engineer the prompts that you're going to use as part of your query? So what I'm going to do is those two PDFs that I just gave you, I'm going to upload those as context to the ChatGPT platform. And I have a sample prompt that I typed up before that is related to analyzing a comprehensive economic development strategy for the Centralina region. So I'm telling the model that I wanted to create a prompt based on this context to analyze this report. So I'll go ahead and submit that. So I gave it one sentence and it will spit me back out a basic version 1 of the prompt canvas framework. So you now have a very comprehensive prompt that gives the model a role. It says what the task and intent are based on what you have, gives you the context and references that will be provided, and an output and the step-by-step instructions that are associated with it. So if I now just take let's see if I can quickly identify this. We'll see if this is it. I will say run this prompt on this document. It will take a moment to read the document, and then the output will probably take a minute or two to generate because it's a pretty comprehensive document, but it will follow these specific instructions within the prompt. So I won't spend too much more time here within ChatGPT, but just to highlight, it can generate text summaries. It's giving me a comparison ready table as part of the output, and it will keep going. So the other tool that I wanted to show you all that I think is really a cool AI tool
Hey,
is,
Jacob, I'm
Mhm.
so sorry. I do not mean to cut you off or jump in. Just keeping an eye on time, could we keep it to just ChatGPT for the example today? And if we don't have many questions, we can return to these examples in a moment.
Yeah, absolutely. Yeah, I
Thank
looked right at time, so I will stop sharing, and I'm more than happy to answer questions via email and things like that. But Mike, I'll turn it over to you. And thanks, Marissa, for keeping me on time here.
Thank you, Jacob, and thank you for the introduction to a lot of the technical complexity of some of these AI models. Really appreciate it. I'm Michael Hogan. I am an economist at RTI, and I'll be the first to say that I am not an AI expert. So I come in seeing how we can use Gen AI to take some of these tools that Jacob has talked about, and he said, just try them and experiment. And so my experience and what I'm going to share today speaks from really this process of experimentation and using OpenAI, in this case, OpenAI Deep Research, but using Gen AI as part of that process of learning and that process of starting to answer applied economic development questions. So my goal today, and as Jacob discussed earlier, an advantage of Gen AI in economic development is the ability to gather a mix of distinct inputs, bringing together job postings, profiles, business incentives, business data, industry data, government data, et cetera, to identify partners, to narrow your findings, and to get to a faster, actionable output. Gen AI can be a very valuable tool to economic development organizations that are looking to stretch limited capacity and improve their processes. And at the same time, it has limitations and there are some risks. To look at this, I want to talk through 3 scenarios that I worked through earlier this year where I used Gen AI tools to answer applied economic development questions. The first is, what is my region's competitive advantage? Where should I be dedicating my personnel, resources, and efforts? The second is, how do I understand the assets in my region, particularly in an emerging or cross-cutting sector? And then third, how can we develop a strategic plan for a new economic development organization? So we'll look very briefly at each of these 3 scenarios, and I hope I can offer some insights into what we learned and provide a few lessons learned from our experience. I ran all of these through OpenAI Deep Research. This is available with a ChatGPT paid subscription in March and April of this year. So with that in mind, I'm aware that these tools are evolving very rapidly, and what was working a certain way 4 months ago might be different today. Additionally, other tools like Gemini or Anthropic might give different outputs or look at different sources. So the first question that I queried to OpenAI was to gather data on the economic trends in North Carolina's semiconductor industry over the last 5 years. This would include workforce size, major companies operating in the state, and current job openings. After about 15 minutes, OpenAI Deep Research came back with a compiled and bulleted report. It was about 10 pages long, and it had content around 4 major topic areas: key companies and investments, workforce size and trends, and impact to the state's economy and state and federal incentives. This included a number of really valuable findings and insights and a lot of talking points that are listed here. So it included our key companies, 110 firms, $1.2 billion in semiconductor and microelectronics exports, 5,000 to 8,000 jobs in North Carolina, open jobs, and estimated growth in the future. Where was demand coming from? So semiconductor techs, engineers, electrical, mechanical, workforce assets. It gave us some high-level talking points on impact to the state economy. So value of annual economic output, exports, wages, and opportunities. And finally, offered a short synopsis of some federal and state incentives. So overall, this was on the surface a valuable 15-minute quick starting place for this work. And I felt like we were left with a really valuable set of background data that could be used to inform a proposal or a pitch for investment. At the same time, we were working on a in-depth analysis of the workforce. So we were able to start to do a reality check and see some of the strengths and drawbacks to this approach. The first, as we said, the strengths, we were able to get really quick and easy talking points. We were able to get names of key players and key policies to consider. And this took about 15 minutes. So it was a real strength that it could assess and compile this information quickly and provide some of the sources. The drawbacks was that the access to the sources was really limited and sort of outdated. So as we started looking at the sources, it was a lot of press releases, public data releases, but there was no primary data or no access to any paywalled news sources. So give the example of the North Carolina Department of Commerce was putting out a lot of announcements around Wolfspeed's growth and expansions, when in reality, the company was going through bankruptcy at the time. So some of the data was outdated, and to us, it was a warning sign about something Jacob mentioned earlier about over-reliance on these models, that they might not be fully reflective of what's going on and might bring up some contrary or outdated information. My second query was around cybersecurity workforce and workforce assets. As many of you know, cybersecurity is a messy and rapidly evolving field, and a lot of employers are struggling with cybersecurity workers. They see big gaps in their workforce. So we asked it to gather a list of all the public and private institutions in North Carolina that offer associates, bachelor's, and master's degrees in cybersecurity, including both accredited and those that do not receive Department of Education funding. The output it gave us was a long, over 20-page list of programs that used web scraping and a mix of sources, including some of the individual websites and some things like the state university system and community college system. It gave us an output of 10 public universities, 18 community colleges, 6 private nonprofit universities, and 6 for-profit or other providers. So similar, this exercise was something that we were doing in parallel with a project. So we were able to look critically and see some of the strengths and drawbacks. And what we saw was that there was a strength in that it brings together these disparate data sources. Cybersecurity is usually not very well captured by traditional data sources, and programs can tend to be cataloged in different ways. Some may be pure cybersecurity, some may be computer science, computer engineering, and also traditional universities and non-traditional credential providers are generally hard to compare side by side. So we were able to bring those together, but there were a lot of drawbacks. As we said, there were some inaccurate, miscategorized, and missing data. There were key programs that were missing from the list: Duke, Wake Forest, Elon, UNC Chapel Hill. It was confusing how they grouped some of the nonprofit providers and the boot camp programs. It relied too much on web scraping from program websites, and the output was just a bulleted text list. So it made it very hard to filter or work through. And then the third one was we looked to how OpenAI could create a strategy for us. So the prompt was to support standing up an entrepreneurial support organization in a state, in this case, West Virginia. So we prompted it to research 4 to 5 similar regions that have successful entrepreneurial ecosystems, Appalachian focus, We want to look at the structures, operational models, and sustainability and develop a report. And it did that. Within about 15 minutes, it developed a pretty pleasant, well-written executive summary, and it had a strategic plan. It had a set of comparative programs looking at Kentucky, Ohio, North Carolina, Tennessee, Alabama, that had entrepreneurs at the center. It provided a suggestion for an operational model to create a public-private partnership with a nonprofit hub. It gave us a funding source for sustainability, a strategic roadmap, and a stakeholder engagement strategy by creating a statewide entrepreneurship council. So within about 15 minutes, we were able to see a lot of strengths in this report. It was very quick. It was very easy to digest. It was concise, gave us that 5 bullet point executive summary that got to the point and really helped us to get a starting place of what a potential strategy would look like. We got a really good high-level understanding of the landscape and the options. And if you were somebody coming in with absolutely no background on entrepreneurial programs or state programs, this could be a very helpful starting place. However, it was by no means a complete document. And when we looked into the details, it became increasingly generic and not very locally informed. And then as we looked through the citations, we found that nearly all of the report was lifted from a 2018 ARC report on entrepreneurship in Appalachia, which put us in a position where we saw that most of this was just copied or paraphrased from another report. So it showed us the way that we should start to think through these Gen AI tools for strategy design, but also really kind of highlighted some of their limitations and over the concerns about relying on a tool like this to answer these kinds of questions. So I just wanted to give a couple of final thoughts, which are going to mirror a few things that Jacob mentioned. I'm looking at it from a little bit more of, I'm less of an expert in the AI field, but see how some of these economic development questions could be answered. So what worked? It was very useful for compiling and summarizing. It was very good for getting a, within an hour, getting a very cursory understanding on a brand new field, brand new topic. It was helpful to find public sources and references. So deep research tools, specifically thinking of ChatGPT Pro, includes the sources and references. And specific prompting, as Jacob mentioned, made your answers better. But there was a lot for us that didn't work. It relied a lot on unverified sources. So web scraping, these are public press releases, public websites, and non-paywalled news sources. They might be biased, they might be outdated. So they're not pulling from sources like Wall Street Journal, New York Times, Washington Post, Bloomberg. And so verifying some of that data, viewing the original sources, seeing that original data can help give additional context. We found that the writing quality tended to be poor and somewhat generic. There were a lot of long bulleted lists. It got a little repetitive, and there were errors and risks of plagiarism. Like I mentioned, this very good looking synopsis turns out it was mostly lifted from an existing report that had been written several years ago. And then, as Jacob mentioned, sometimes there was a failure to follow prompts, and it would answer those questions in a roundabout or confusing way. So for me, I wanted to leave you with these few thoughts, thinking about it from the perspective of a practitioner, of working through some of these questions, starting to see a few concrete ways that we could start to push and experiment a little bit and learn a couple lessons about what worked for us and what didn't work for us. So I'm going to stop here, and I'm going to kind of open it up and hand it back over to Marissa for discussion.
Yeah, thank you so much, Mike. Would love to take any questions from the audience. I know we had a couple in the chat that I think we've addressed, but if not, please feel free to raise your hand or just unmute and call that out. At this point, I'll also launch that poll that Sarah introduced in the chat. So 2 brief questions, just thinking about one of the slides that Jacob had shared earlier in the presentation, thinking about specific tasks that you use on a daily basis in your economic development work, and then how AI can really support those tasks. I like to think about AI as an assistant to my tasks. So we'd love to tailor these future workshops to you and your needs. So at this point, any questions? or Sarah and Jess, I'll welcome you to hop in as well if you'd like to share anything.
I'll just share, as we've always done with the community practice, we are eager to design these future sessions based on where you all are and where you want to explore together. Jacob, this session, as I mentioned earlier in the chat, is intended as sort of the 101 of AI for economic development. It'll be recorded, it'll be put on our YouTube channel, so you can refer others there. In future sessions, we will pick a topic to work through together in a workshop format. Jacob, feel free to jump in and chime in. I know you're designing these, but we do want to do, the more we focus those on where you are and what you'd like to explore, I think the more useful, or they could resonate with someone else who hadn't thought of that use before. So please do either in the chat or feel free to email and let us know what you think would be great for this group to explore together, and we'll be designing those accordingly. And Jacob, I don't know if you want to add anything to that.
Yeah, I think it's a great overview. And, one of the things that we have a strength in at RTI is, the group that I work within is really trying to maintain itself at the frontier of the capabilities of these tools and the different tools that are emerging. So if there's a particular use case that you've, found like, well, this tool doesn't work really well for it, or I would really love to learn how to understand if this particular tool can be used for this particular use case, or maybe it's a very specific, data analysis question or something like that. I think any context that you all can provide as it relates to those use cases, when we come to the workshop sessions, we can make sure to come prepared to share, what our understanding of the best tool might be for a particular use case. And bring folks who are familiar with working with those tools to actually be able to help you out in working through an example. So really, experimentation is kind of key, because the ChatGPT you use today is the worst version of ChatGPT you're ever going to use. So the capabilities are going to continue to evolve, and these tools have already gotten to the point where they can take a prompt and actually write code to do data analysis, and then write the code to create you a dashboard from that data in kind of an agentic fashion. So we would love to think creatively about how these tools might be able to be used within your workflows. So any examples or thoughts you have on coming up to the workshop, we would welcome those. And then we can let you know if you need to try to get access to a particular tool to trial for that workshop session ahead of time as well.
Great. Well, if there are no questions, Jacob, I would welcome you to walk through another example. We have 5 minutes.
Sure, I would be happy to. And anyone, feel free to interrupt me if needed. I'll go back to the Google Notebook LM example. Has anyone on this call used Notebook LM? Any hands there? So Notebook LM is basically what Google's version of taking the Gemini model and implanting it into a user interface that can be used to query a set of documents. So Mike highlighted the capabilities of AI to help synthesize information. So if I move this particular bar out of the way, Google Notebook LM is very simple to log into with your Google account. If you're worried about getting personal and private information mixed up, you can create your own Gmail for professional purposes. So all I've done within this notebook is added I think it was 4 different EDA annual reports. Those come over here. It can input YouTube videos, other types of documents, websites, etc. And then you can actually select which of the documents you want to query within the Notebook LM interface. So from these 4 reports, I was just playing around to give some demo examples. I just asked what themes have seen the most investment over the past 5 years. And it goes through all of the documents, and it actually provides an output that is based on the information provided. it's retrieving that context from these documents, and then it actually gives you a citation to the specific content. So to the point that Mike was making earlier about these things can hallucinate, we talked about one of the mitigation methods to that is actually providing relevant context as part of your use of the model. So when you upload these documents, you'll get specific text from the document that was retrieved. So you can see the response to that first question was pretty robust. I also asked if diving a little bit deeper, if it could provide me examples for a specific area that it highlighted, and then it actually went through and provided for each fiscal year all of the examples and the quantities associated with that. So it's a really cool platform when you have a set of documents that you want to query using AI. There's a lot of interesting features in this. If you have a document that you want to turn into a mind map, or if you're an auditory learner, for instance, and you don't want to sit through reading for reports, you just want the high-level key takeaways. Within Notebook LM, you can actually generate a podcast-style audio summary automatically. So maybe you're going to go for a walk outside during your lunch break and you want to listen to a summary of all of the economic development annual reports from the past 4 years. You can do that. And when you create this audio summary, the other cool feature is it's in beta right now, but you can stop the conversation and actually ask a question with your voice, and it will respond to your voice, incorporating it back into the podcast. So you can get real-time feedback on something that you thought was interesting based on the original kind of podcast. There's other features within here that you can play around with, but this is one of the tools that I go to most often, specifically when doing research, because it does provide you that data-backed, cited answers to the questions that you're asking.
I have a simple question. You probably said it, but does it only pull from what you have to the left?
So just like any other large language model, this Notebook LM platform is based on Gemini, which was trained also on the entirety of the internet. So there is still a chance that it can make hallucinations, and it can pull content from the data that it was trained on and insert it into the answers that it provides. But it's generally, in my experience, much more accurate than just asking a question to a basic LLM.
Thank you.
Awesome. And that brings us right to the top of the hour and the end of this first session. So thank you so much, everyone, for joining our foundational discussion today. And I'll just encourage you to register for sessions 2 and 3. Our next session is on August 12th. And if you didn't grab the registration link from the chat, you can absolutely visit our website for our upcoming events. All right. Thank you, everyone. Thank you so much, Jacob and Mike.
Thanks,
Thank
everyone.
you.